So the whole course will be on R, all programs written on R. It will not be an intensive R code course. I'll provide the code, but it's important to play with the code as the video goes along. So every week before the video starts, I will issue an R script file, which has all the R code that will come on the slides on the right-hand side. So this week's one I have uploaded on RStudio. It's called week 1 notes.r. You can play with it as I go along the class. So before I get there, I just want to comment a few things on R. So one thing is that R is a free software that's available for everybody. And one of the things I like about R is that it's quite attractive, and I really like it in terms of its usability. And again, this okay. So it's available on all platforms, Linux, Macs, and Windows. And the project webpage of R also is very, very useful, and one can understand many things of it. And it's been around for quite some time, and I use it quite well, quite often. So I really recommend it in many ways. Okay, this is I have like this check what's going on. A second. Okay. So here, there's wide help on the web. So there's help available. So that's something you must use about R. There are a lot of groups. There's even an R blogger website that has help on R. So I'd encourage you to use them as you go through this program and this course in this sense. Very good. So these just a few words about R. R came after a program called S, and then S went to S plus, and S was developed in the 18 labs. I don't know if you're aware of this. It's late 80s, and it closed down in the 90s. And then the R project was started by two statisticians, Robert Gentleman and Ross Ihaka. They were in New Zealand. And this first paper, if you haven't read a paper on a statistical software package, I encourage you to read this paper. I will leave a link of this on the website. This tells you how they started R and how the software was built in the beginning. And the way it was built as a collaborative project. And now it's huge. It has many, many contributors, and it's maintained by a core development team. Right? Okay. So this, I think you must have done already in your previous classes in this program. If you have not done it, please download R. It's essential for this class. And also RStudio, I would recommend. This is what you see on the right-hand side here. I would recommend that as well to sort of work with it. Very good. So let me just start with just data for this class in some sense. So broadly, there'll be three kinds of data. So one is called categorical data, and one is discrete numeric and continuous numeric. So both data sets here are like going to be numbers in some sense. So so if I have to classify this, sorry, let me go back. So these are both numbers. So they'll have some numerical value, and there'll be some numbers. And this is more like categorical data. So in the sense that what will happen is that here, it'll either be 0 or 1, or some kind. It'll be A or B. So each, or many more things, but each will be a category. It will not be a numeric value in this set. But in both these things, there will be numerics. In discrete, I mean, in terms of discrete numeric data, means it will only take integer values or a certain number of rational values. Continuous mean can take anywhere in the real line. Of course, there are many ways of classifying data. If you go to this original paper, 1946 by Stevens, they'll give you a 9-category classification of data. And that itself is sort of a nice read as well. I will put both these papers on the course website. You can take a look at it as the course progresses along. So for this class, I'll mainly work in the beginning with discrete numerical data, and then slowly move on to categories. And today itself, I will give you some categorical data as well, but largely we'll work with numeric data. So the formal philosophy is that most data are given in terms of numbers, and So this, like, for example, let's say if you look at daily data, let's say you get daily data of temperature, for example, that's a thing of data of temperature. So that's a clear numeric data. Or let's say earnings of a company, let's say earnings of in a stock market. So these are all data comes in the form of with regard to time, and each time point has a certain number describing the thing. Sometimes you may have many variables that naturally take on discrete values, like you could think of it as a number of people with a certain characteristic, or number of cells and characteristics, and so forth. And this I will do as I go along, but just to you should just sort of review for yourself. Box plots and histograms. If you haven't seen this in your previous classes, let me know. I will review it in the future. But as of now, I'll assume that you know what a box plot is and histogram is for seeing this data set. So if you give you a data set, I give you a data set, the first thing is to understand some broad features of it. So first is what's called the center, next is the spread and the shape. So let me draw a picture and then sort of indicate to you. So for example, let's take a simple normal data set, let's say. So let's say this is the axis, put the axis right here, and say y-axis right here. And then let's say my density function looked like standard, like it went up like this and came down like this, for example. Right. So first thing you will say is that you know how to identify the center, right? You'll immediately say if this will be the center of the distribution. That will be central distribution. That's something you'll immediately identify as part of the data set. Okay. And then the next thing you might say is that if someone will ask you what the spread is, you might say, okay, fine, I'll think of this as the essential spread, because beyond this, the tail is so small that the chance of finding a set point in this part of the region is very, very small. So maybe I'll do a different color. So you'd go ahead and say, okay, if in this part, I will not find a data set, the point data set, because the probabilities are very small. And this kind of the spread of the thing. And the shape, you would regard this whole thing as the shape of the distribution, right? So what will you observe about the shape? Let's see. So first quality you'll observe about the shape is that you would say it's symmetric, right? So the shape is it's symmetric around 0. So that's a characteristic about the shape that you do. Let me give you another one. Let's say if you have done some probability, you're immediately seeing, let's say you have gamma, let's say. So that let's sort of let's sort of access this way in different color this time. So this one, and let's use blue to the thing. It may not be symmetric. It may just be around 0. It might start at 0. It might climb up, and then it might climb down to that. Right? So, okay. This is like how a gamma would look like. If you have not seen, let me write this down. So we are on the same page. This is what I would call as a normal distribution, right? Just give me a gut feel, and this will be like a gamma, for example, with some parameters, which are not normal, with some parameters. So here again, you have to identify. Let's say I'll let you think about it. What's the center of the distribution? You think about this of a gamma. Like where would you in your head, what would you think of center? Next thing also you would think of it is you have to understand what the spread is. Like what's the notion of a spread? Like how would you understand the spread? In the normal case, the spread was kind of easy. You try to think around the mean where the data was spread. And the shape, again, you can easily understand it is not symmetric. So it's like sort of asymmetric. It's not asymmetric. So these are some initial intuitive understandings of data sets. If I draw a distribution in mind or known distributions in mind, I immediately come to the conclusion that I have different shapes available for me to play with. Okay, very good. So let me now formally define these three things. My slide a little cluttered, but let's see. Let me make it a little bigger so you can see it. Maybe that's good. Okay. So Maybe I can make it a little bigger so I can see the whole screen, but come back and do R. So center typically is for a data set is usually the mean, or the average value of the data set. So again, it's numeric data set, it's not a categorical data. So I can talk of a center. Of course, other measures include the median and the mode. So mode means that the one with the highest frequency data set, median is the one that is sort of in the middle, and mean. So there are various ways of understanding the mean. So let me just play with the mean a little bit. Let me just go back up here and play with the mean a little bit. So the mean, one can think of it in many ways, right? So suppose fi was the frequency of the value xi. So summation x fi times xi. If you have n point data set, and then you divide that by this and divide by the total number of frequency. There's the total number of point data set. So n is the distinct number of numeric and data set, and fi the frequency of each of them. This would come out kind of understand the mean, right? So when someone tells you what the mean is, you can think of it in the following way, right? So you have these, you have a line like this, and you have x1, and let's say I order them, and you have xn, and then each of these points I put fi amount of sand each of them. So let's say xi, I put fi amount of sand. Then the mean is something like this. So the mean is somewhere here. Means that if I go and take this board and balance my hand there, that's where the board will balance with all these particles of sand. Let's say fi weight at each point. So I have f1 at this point and fn at this point. That's all. That's one way of understanding the mean, right? This would be the mean. So this would be the, let's say this is called mean, and that would be the mean right here. And mean may not be any point in the data set, can be something else, but we understand the mean in this particular. The spread. So this is how I understood the mean. So I'll leave it like this. So the next thing, let me try and understand the spread a little bit. So let me try and understand spread a little bit. So spread typically is indicates the variability in data set. So usually you want to understand, like in the normal case of a symmetric data set, or if the data could have some very, very few large values, but everybody is very, very small. So it'll have a mean somewhere in the middle, but large variance in some sense. So one has to understand how to sort of, the spread is a good measure of understanding variable data set. Okay. So what one does typically is that there are several notions. So one is one computes what's called the variance, and one takes essentially this is what I would call it as, you can use the spread in this fashion. One takes the essential range of a data set. Okay. This again with a pinch of salt. It's not really a scientific term to understand this. So you could take a mean, you take the mean minus standard deviation, and then you take the interval mean plus standard deviation. So that's some interval, right? So these are 2 points of real line. So let's say that's point right here, mean is right here, and and I draw this line. So I draw this line, and let's say the actual mean was somewhere in the middle, because I've taken, this is the point mean minus standard, this is mean. So let me lower this down so it's sort of clear. So very nice. I go back up here, right? So one thinks of this as the actual spread of the data set, or one thinks of mean minus SD, because I took a scale 1. So mean minus SD, I start here, I go up to here, as the essential range of the data set. So, I mean, of course, it's not quite the range. You could have points somewhere here as well, but formally speaking, this is what you would call as the essential range, right? And that is what's given by the spread. Of course, now you don't have to stop with 1. Some people might take mean minus 3 SD and mean plus 3 SD and so on and so forth to sort of indicate the true range of the data set, or closer to range. So that means, so the idea is that these points outside have very low frequency or very low chance of occurring in the distribution. That's what you understand by the spread of this. The next intuitive thing to understand is what's the shape, right? The shape can be like you just go back to the previous slide. these are the two shapes that you keep in mind. One is symmetric, one is right skewed, and one can have left skewed. So you have three sort of ways of understanding shape. And once you plot the histogram or the box plot, you can understand if it's going to be symmetric around the mean or the median, or it's going to have a skew around one side. And these tell you something intuitive about how the data set is sort of shaped and how the sand is floating in this pile of across this orange board, right? Pink board, right? Okay. Very nice. Okay. So let's go to the first coding aspect. R has a lot of data sets. So let me just make this screen half now. Let me screen this screen half. It's too small. Okay. I hope you all can see it. So here, so R has a lot of inbuilt data sets. So it means by means of inbuilt, I mean inside R there's lots of data sets. So and this is a very useful collection. So it's a very useful collection, and I strongly encourage you to play with it. So I strongly encourage you to work with it. So any concept you learn in the class, I would strongly encourage you to find a data set in R and do problems and repeat experiments. I'll just call repeat experiments done in class. Of course, you may not find a correct one, but you'll have to go and search for it. So today I'll do some experiments, like I'll draw some pictures. You should go to R, look at data sets. So let's try and see how this performs. Let's go back to the R studio on the left-hand side right here. Let me come here. Let me see if it's working. Very good. So the first thing was data, right? This is what the notice. So if I plug that in, so if I enter that in, so see, it'll give me all the data sets available in R. So it has air passengers and give you a small description of what the data set looks like. There's BOD, that's called the biological oxygen demand. This is related to sewer treatment plants and how wastewater rises. This carbon dioxide uptake in task plants. So there's a variety of data sets available for you immediately. Tooth growth is something that people play with quite a bit. There's admissions at UC Berkeley that's given to you, and so on and so forth. And then there's air quality. We play with some of the data sets today. There's a volcano data set called Faithful that I play with quite often, and so on and so forth. There's several things available for you. And so each is a sort of an interesting data set, and I want you to understand how to work with them in some sense. So if you just type in data, it'll give you all the data sets in R. So I encourage you to play along with the R as the class goes along to get an understanding of how to work with R and the commands as well. So this is what I told you. It gives you a big list. So this list just contains quite a lot of data sets. So it gives you a comprehensive list. Write it down. So provides a comprehensive list. Okay. So how does R store data sets? So R store data sets in what's called a data frame. I don't know if you have played it in this course, but we will use data frames regularly in this class as I go along. Right? It will not be a one-off thing. So a data frame, in the most simplistic fashion, is just a rectangle collection of variables in the columns and the rows. So it's just a rectangle collection of variables. There's nothing more to it than that. So one can work with the data frame in many ways, and in this class I'll tell you how to do this as we go along. Okay, so the first data set is called air quality. Let's say I just want to know. Let's say we go to my R script again. I just type in what air quality is. So I go here and I just type in air quality, and I get on the right hand side of the window, it tells me exactly what air quality is. It tells me air quality air quality measurements in New York, September to May to September 2003. It also tells me how many observations are there. There's 153 observations and 6 variables. I mean, there's 6 columns and 153 rows. That's what this data set is. And one can understand a little bit more of the data set, and then it also concludes with what the source is and what journal the data set will go. So I encourage you to try this out. It'll give you, it'll describe the data set. So it describes air quality. And then it also describes, it tells you It told you it has 153 observations. That is, there's so many rows are there in the data frame. It has 6 variables. There are 6 columns are there. So now, if you just type air quality in, let's go type air quality in. Let's type air quality in the beginning. So I have not done that in the notes. You can just take it out. Maybe I'll write it down. If I type air quality, here. So then if I just type this out, then I just get, it'll just be too much. The entire data set is printed for me on the bottom side, and I can't really understand what's going on. It's just too many things going on. If I scroll up and come back, it's just too much going on. So what you do is you type what's called the header data set. So you type the head, it gives you the first 6 rows data set. So it tells you the variables are ozone, solar.r, wind, temperature, month and day, and the values are there again. Some are missing values as well, but that's what it is. You can also go and type in tail. That's the bottom guy. So that's the last 6. It provides the last 6 rows. Right? If you want just the first 10 rows or first 20 rows, you can sort of do this, and you can also plug out various entry data sets. For example, let's say if you go ahead and put 10, it tells you the first 10 rows of the data set right here on the left-hand side right here. And then one can also understand how to do this. Like suppose you have air quality in terms of if you want to go temperature variable and you want to pick the 148 element, you can go type that in. It'll give you in that column, you can pick out this variable and the 148 entry of that column. And then if you want the entire 148th row, you could go and do air quality 148, and then it'll give you the entire 148th row. Ozone, solar, wind, temperature, month. And then of course you can also pick the first 4th column that is all the same as the first and 4th column. So C function can be used to form any vector that you want. It'll enable display entries to the respective columns and rows. We did not specify any row in this, so it gave you all the rows. So it gave you all the rows, the 1st and 4th column. The 1st and 4th column are what? If you go back up all the way, you can check the 1st and 4th column where I think solar and then temperature. Right, that's the 1st and 4th column. Very cool. Then now you can also do summary. Summary air quality will give you exactly the precise summary of the data set. Right? So what it tells you is that it tells you that the variable temperature right here that I have, air quality, which is how I called it, it has a minimum of 56 and a maximum 97, and the mean and the median are on this range. So it gives you a 5-number summary, the median, the 1st quartile, the 3rd quartile, and so on. And then you can also plot the histogram. If you plot histogram, it'll come on the right-hand side. Hopefully it'll come here. Let's see if I can get it. It's a little small. Let me make it a little bigger. So that gives you histogram. That's what I have on the left-hand side as well. So R will do it for you by itself. Nothing else to do. You'll just do a histogram. And how it choose the bins is a certain technique that one should go and check the histogram help menu to see how it plucks the bins by itself. Then I can also do a simple scatter plot of air quality, which is what I've done here. So I go here, I just plot of air core temperature data set, of temperature variable. So it'll just give me a simple scatter plot of the whole thing. Now I can also do a dual scatter plot. I can just do air quality versus ozone. So that'll just give me an air quality ozone. If I do that, I just get an air quality. So I get this on both sides. I get ozone on the x-axis and then temperature on the y-axis. That's how the command is split up. So if I have a command like this, that is if I plot ozone on X and temperature on Y, which is what it's doing like this. Then the last thing I've done is I just plotted air quality. It'll plot everybody in one shot. So let me just show you that as well. And if I just plot air quality, it just gives you a scatter plot of everybody. So it gives you a sort of all the variables on X equal to X is just the variable names it'll give you on the diagonal. And this will just be an ozone versus solar, and then this will be an solar versus ozone, and so on and so forth. And everything is like wind versus ozone, and this is like wind and temperature, and everything, and wind and month, and so on. Before that, let's do the following. So these have to be installed in R. So how we install in R is you have to go and install a package called using R, which I'll use quite regularly in the program, in this course. So the way to install a package is you type in this command, install our packages using R. So for example, in my thing, I've already installed it. So if I go and run this program, installer packages, it'll just say it's already installed for me, but you have to go and install it if you want. Or maybe not. I don't have installed the machine. So it's installing by itself, as you can see on the left-hand side. It's installing using our packages. So it's done, and then it says the packages are available in this directory, which you don't have to worry about. But suppose you want to use it, you have to type in this command called library using R. That's what I've said here also in this line. So you type in and then do slide library using R. So you do that. So the bracket I forgot. Yeah, I'll just go and put the bracket here. So now it's loaded all the package, and using R has all these packages already. Like it needs mass and history and so forth. And it also gives you a certain warnings about the message you can ignore typically, and then it does. So now, if you do a simple exercise, you go and type in data now, it'll have many more data sets than before. You can just check it. Sorry. Now, there'll be many, many more data than before because I've included also the using R package. It'll have many more than before. If you can easily notice it. Because, for example, last time we stopped very quickly, but now I've added a package called using R. It has many, many more data sets, which we'll use for the courses. The last package I'll need today, and I'll need is called tidyverse, which I'll encourage you to install. So you type in called installer packages and tidyverse. So I'll do that. So let me do that. So let's type data. So this is something you should install if you haven't installed it. You should install tidyverse. If I do it for me, I think it'll already be there. It'll say it's already there, but it might try also. It's going to update my packages. So let me update it. Okay. So it's done. It's done. Okay, very good. So then I did library tidyverse, it'll install library as well.